graphical inequalities. So these are a bit harder than the other inequalities because to find the solution you do kind of a quick sketch for a graph. So if I'm just going to introduce it and show these rules, but rules I wouldn't learn because I would draw the graph. So these rules would apply to things like if I have x squared is greater than 9 and I want to solve that. And we know that when we have something squared, we end up with two possible answers because you can get the positive or the negative. So for example, if this was just an equal sign, x squared equals 9, I would take the square root, but I know it would be plus or minus the square root of 9. So the answer would either be plus or minus 3. So I have x equals 3 or x equals minus 3. So I have two answers. Same applies for if I have an inequality, but the way this one would work is my answer would be x is greater than 3 or x is less than minus 3. And how do you know which way to put those signs and stuff like that is why we have these rules that you can just remember, or you can kind of understand and learn how to do them and then, not get them wrong. Okay, so here are the rules, so we'll look at examples of these then. So we have x squared is greater than a squared, then you get x is greater than a, or x is less than minus a, and then that one for that one. If it was or equal to, you would add or equal to signs here. So let's try an example. If I had x squared is less than or equal to minus 4, I could look at these rules, and so my x squared is that, my a squared is 4, so it's this one, but with an equals to sign. So I could know that x, and then I could put these here, and then a, so a squared is 4, so a is either minus 2 or 2. So that's how I could use the rule, but I'm going to show you on a graph and some more advanced ones that I really prefer the graph method. Okay, so the first example I'm going to run through with the graph before we go on to exam questions to practice is the one we've just done. So I can rewrite this in as x squared, and then I can take the 4 over and do minus 4 is less than or equal to 0. Now this looks like a quadratic, so if we remember, quadratics is something in the form with the highest order x squared in this form. And we have done, when factorising and solving quadratics video, we did, when they were equal to 0, you can solve them. So that's what we're going to do here. So we look at this, and I'm just going to replace the inequality sign with an equal sign. Now I want to factorise this, and this is dots. This is a difference of two squares. The way you do that is x plus 2, x minus 2 equals 0. And for two things multiplied together to equal 0, that means one of them has to be 0. So either x plus 2 equals 0, or x minus 2 equals 0. So if I solve those, I get x equals, if I take the minus 2 over, I get 2, or x, if I take the plus 2 over, I get minus 2. Okay, now if I think of this in a graphical way, I could think of the graph as y equals x squared minus 4, this thing. This thing. So if I've set that to equal 0, really I'm saying that y is 0. So when y is 0, I'm getting the values x equals minus 2 or 2. So let's plot that on a graph. So here is my graph, and I know it's a quadratic, so I know it's going to be a curve. And I know it's positive, so I know it's going to be a smiley face one facing this way. I know that when y is 0, x is these values. So the values you work out here are when y is 0. So they're the x-intercepts you work out basically when you end up factorising. So 2 and minus 2. And I know it will look something like this because it's quadratic and it's a happy face. Okay, perfect. This is why it's extremely helpful. So now we want to know when the values are, so this is when we go back to the inequality. This is the only time we actually consider the inequality now. We want to know when this thing is less than or equal to 0, and we've called this thing y. So we basically are saying we want to know when y is less than or equal to 0. So y is less than or equal to 0 all along down this part. So from there down, and in our graph we can see that that is these values here. So then we can see that x is, and then because it's equal to, we can then write the x values are -2 equal to, because it's equal to in the question. So we're writing out this inequality here, these values here on the x line. So that's an example, and now we're going to do a lot more exam questions to practice. Okay, so here we have an inequality and a quadratic, so we know we're going to have to draw it on a graph. So first thing we do is we pretend that it's not an inequality and we solve it equaling 0. So to solve a quadratic we have to factorise it and make those brackets equal 0. So first thing we do is coefficient of x squared is just 1. So we need a number that multiplies to give -20 and adds to give the x coefficient -1. And then we're going to put those in there. So what are those numbers? Those numbers are going to be 4 and -5, because 4 times -5 is -20, and 4 take away 5 is -1. So we can write either one in each bracket. Okay, now just continuing to solve this. Two things multiplied together to give 0. One of them must be 0. So that would give me x equals, take the 4 over, -4, x -5 equals 0, take the 5 over, x equals 5. Okay, so as I showed before, that is technically, if we're thinking about sketching on a graph, so let's say y equals x squared minus x minus 20 equals 0, that is saying then y is 0. So these values are the x-intercepts, so the points where it crosses the x-axis. So this is how you can basically sketch them so nicely. So -4, and we'll say that's 5. Doesn't have to be perfect, it's a sketch. We know it's a quadratic because it's got this highest order term here, and it's positive, so it's going to look something like that. Now we go back and consider the inequality. So it's saying when it's less than 0, so basically we're kind of saying now that y is less than 0. So we're looking for the values where y is less than 0, so these ones are all positive, if we were going to draw them on, and then these ones are all negative. So this is when it's less than 0. Okay, so what are the x values when it's less than 0? So it's these bits here, so from there to there. So we've got -4. This time it's not all equal to, so you just leave this symbol here. So x can take the values between all these values here, from -4 to 5, and it's not equal to because it's not equal to in the question. So that's how you do that. It is kind of tricky, but it kind of looks really nice. Okay, so very similar again. So obviously, as you can see with these, practice makes perfect. Solve x squared minus 7x plus 12 is less than or equal to 0. It's a quadratic inequality, so we know that we're going to be drawing, sketching the graph and all that jazz. So first of all, we solve it as if it's equal to 0. So we need to factorise the quadratic, so we need a number that times is to give 12 and adds to give -7, and that is going to be -3 and -4. So if -3 times -4 is 12, -3 minus 4 is -7. So let's put those two in our brackets, so -3 minus 4. So for two things to multiply together to give 0, one of these brackets has to be 0. So x minus 3 is 0, so take the 3 over, take the -3 over, or x minus 4 equals 0, take the -4 over, it becomes, there we go. So as we've just seen, but I'll go through it again, they are the x-intercepts, the points at which it crosses the x-axis. So to draw a sketch, we know it's a quadratic, again it's positive, so it's a happy face. It's just going to be something like that. And the reason that it is the x-intercepts is because we're sketching the graph y equals x squared minus 7x plus 12, and we've set it to equal 0, so technically we're saying y is equal to 0. So when y is equal to 0, it's along this line, so you're finding the x-intercepts. Now, what was it actually asking for? This is the part where you actually start to consider the inequality. So it said less than or equal to 0. So basically it's saying when y on our graph is less than or equal to 0. So again, we know y is less than or equal to 0 when the values go below this line here. So in our example from our sketch, that's those values there. So that is when the x values can take any along this line. So they can go from 3, they can go in between 3 and 4, and because it has an or equal to sign in the question, you can put them in your answer. Well, not you can, you have to. So let's do another one. Okay, so here we have another example, slightly hidden. So we can see there's quadratic evenness like stuff going on because the highest order term is a squared, and we can see it's got an inequality. So first thing I'm going to do is rearrange this into the form I like. So bring these two over. So it's plus 8 on that side, minus 8 here, plus 9 there, take it over there. Inequality sign doesn't change because we're not multiplying or dividing by a negative number. Now that looks more like what we've just been doing. So let's follow the recipe, do the method we've just been doing. So first of all, we set it to equal 0 and we solve. So when we solve, we have to quadratics, we have to factorise them. So let's find out what goes in here. So we need a number that multiplies to give minus 9 and adds to give negative 8. So that is going to be minus 9 and 1, because minus 9 multiplied by 1 is not minus 9, minus 9 plus 1 is minus 8. So minus 9 here, plus 1 here. Two things multiplied to give 0, one of them must be 0. So one of these brackets must be 0. So x, and then take 9 over plus 9. X plus 1 equals 0. Take the plus 1 over, we get negative 1. Okay, and as I've just shown, so technically if we're sketching a graph, the graph we're going to be sketching is x squared minus 8x minus 9 equals 0. This graph here, so technically we're saying that y is equal to 0. So we found the values that satisfy this equation, so for when y is equal to 0, which is the x-axis, so we found the points in which the x-intercept points basically, and that's how we can sketch. So again, we know it's a quadratic, so we know it's just that happy face or sad face. It's a happy face because it's a positive quadratic, and we found the points in which intercept, so rough sketch, it looks something like that. Now, this comes to the point where you actually consider the inequality. So the inequality is, in this graph, we're saying it is, from here, bigger than 0. So we're saying when y is bigger than 0. So we want all the values and when y is bigger than 0. So all the values that will give us these outputs, the ones where y is bigger than 0. So from our graph, we can see, these are the ones where it's less than 0. So it's all the ones this way and this side. So I hope that makes sense. So all of the values here will give values, all the x values here will give output y values which are bigger than 0, and all the x values this way will output y values which are bigger than 0. So that means the x values it can take are these ones or these ones. So that's either x has to be less than minus 1, less than, so small side, and it's not or equal to because we don't have that in the question, or x has to be greater than 9. So we can either take these values or these values. Okay, so this is another exam question. So work out the integer values that satisfy x squared minus 7x plus 11 is less than 0. So similar to before, except we need to know what integer is, and that's a whole number, so the number line, numbers on the number line, like 1, 2, 3, 4, minus 1, minus 2, etc. However, this time, if we try to solve it this way, we'd be looking for numbers that multiply to give 11 and add to give minus 7. And 11 is a prime number, so the only numbers that multiply to give 11 are 11 and 1, and you can't shuffle them anyway to get minus 7. So we can't actually factorise it. So that calls for, not a panic, but the quadratic formula. Okay, so we know we're going to have to use the quadratic formula. So first of all, let's identify what A, B and C are in our equation. So if I draw out a quadratic, Okay, so what is a in our example? A is just 1, not 0, otherwise the x squared wouldn't exist. 1, be careful there. B is the x coefficient, so number for the x, which is here, minus 7. And C is the bit without an x or an x squared term, and that is 11. So now all we have to do is substitute these numbers into here. So x equals minus b, so minus 7 is 7, plus or minus the square root of minus 7 squared is 49, minus 4 times a, which is just 1, times 11, all divided by 2 times a, 2 times 1, which is 2. Okay, so if I put that into the calculator, the answers I get are these. And this is why you can't factorise it, because you end up with decimal numbers. So these are solutions I've got. So if I now sketch that on a graph, so having these as my x-intercepts, instead of nice whole numbers, I'm going to have to make some room. So I've just sketched this graph here, whilst rubbing a bit out. So, but these are my x-intercepts. But it's saying work out the integer values, I should have said values, that satisfy that this equation is less than 0. So this is the that is the graph we've just drawn. So we want the values less than 0, so these ones here. So technically that would be, our x values can take these, so it would be between 2.38 and 4.62. And we wouldn't do or equal to because it's not or equal to in the question. But what it also isn't in the question is decimals. So we have to have integers. That's why it's written out here. So instead of putting these, we have to take the integer values nearest that are still in there. So instead of 2.38, we have to take 2. So x is between the integer values 2 and 4. Really it's between those, but it specifically asked us for integers, so we have to be a bit more careful. So they don't all have to be quadratic, so they can just be graphs. So I'm going to write out an example of a non-quadratic graphical inequality. Okay, so it's saying shade the region where y is less than x. So to do this, a bit like when we had quadratics, what you do is you draw the graph y, ignoring the inequality for now, is equal to x. So we do have a rough idea of what that looks like. So we're going to do an equally rough sketch. So y is equal to x is this line here. However, because the inequality is not or equal to, what people tend to do is draw a dashed line. If it's equal to, they draw a solid line, but if it's not or equal to, they draw a dashed line. Obviously you can't rub out in on your exam as easy as I can on a whiteboard, so maybe think that through before. So now you want to shade the region where y is less than x. So this is where y is equal to x along here. So you're either going to shade this region or shade this region. And the way you decide which is this. This is the way that I find works best. You pick a value in this region. So let's say it's this one, is 1, 1 is in this region, this side of the line, and then we check. So if we put those, so y is 1, in this y is 1, x equals 1. So if I put that here, so is 1 less than 1? Well, no, that doesn't work, because 1 isn't less than 1, 1 is equal to 1. So therefore we know it cannot be this region, so it has to be this region. So this is the region we shade. So you pick a number. Just to check, because I might, want to do it a bit more than just that once. I'm going to pick maybe this here. I'm going to say that is along the corridor 2 and downstairs minus 2. So I'm saying here that x equals 2 and the y equals minus 2. So if I put that back into my inequality, I have y minus 2 less than x, which is 2. And yes, that works, so I can confirm I've shaded the correct region and also do a dotted line because it's not or equal to. So we'll just do one more other example of that. Okay, so shade the region y is greater or equal to 3. So first we're just going to consider it as y is equal to 3 and sketch that graph. So where y is equal to 3, there's going to be 1, 2, 3. So it's going to be all the values along this line. And this time I can draw a solid line because it's or equal to, so I don't have to make it dashed. So that is the line, should probably label it, y equals 3. But it's saying shade the region y is greater or equal to 3, and in this case it's more obvious that it's going to be the part above, but let's just check a value. So if I check, so it's either going to be above or below. So in my below region, that sounds so dodgy, so in the below region I've got the point x equals 0, y equals 0, so if I substitute, so in the below region I've got this point here, x equals 0, y equals 0, so if I put that here I could put 0, I would substitute 0 is greater or equal to 3. Yeah, nah, that doesn't make sense, does it? So it can't be this region, so we know it's going to be this region, so we know we're going to have to shade this in, but you might just want to do, want to do one more check. So let's say I take this point here, which I'm going to say is along 0 and up about 5. So in the above region we have x equals 0, y is equal to 5. Let's put that into the inequality, so y is 5, greater or equal to 3. Yes it is, so I know I've shaded the correct region. Sometimes you have multiple lines, but you know, just do each line separately. It's not too bad, basically.